which existence have all over world, and some of have the existence in world in India. Sorry. So uh, presently, I have some expertise on 40K firewalls, 40K SD-WAN, Zscaler JTNA, some sort of servers like DNS, DHCP, and how any application need to be hosted in any server. And except that, I have some expertise in CrowdStrike endpoint security as well as the Sophos endpoint security. And in last year, I have done multiple implementation of Meraki Wireless and Meraki LAN as well.
Okay.
So now, during my work experience, I have found some of the gaps. Okay, as due to that, I have identified that is the perfect course for me where I can grow my knowledge on wireless solution, as well as right now my company has create another company which provide the solution for the external clients as well. So that's why it is most required for me as well, because how to generate the heat map, what is the dependency of that part. So I need to understand more on those. So I will be basically total starting my journey on wireless from the scratch.
Okay. Okay. Thank you. Thank you for providing that context, Bisji. I will probably answer your maybe just a couple of points there in quite short, right? So as you can imagine by the title of this course, this will be the CCNP wireless course. So here we will cover some of the basic aspects of wireless, and then we will mostly deal with the designing aspects, right? So if the intent is to understand and deploy and design wireless networks in your professional career, yeah, you are absolutely at the right place. But at the same time, I would also like to inform you and everyone else who is currently on our meeting today that this is not a troubleshooting session, right? This will not be a product training. Although we will, of course, since this is Cisco focused, we will cover the basics of the basic fundamentals of building blocks of Cisco wireless design. But again, this will not be a product training in depth, right? So if that's the expected outcome that you're looking for, maybe this course is not for you or anyone else. But yeah, I just wanted to set the baseline so that we all are on the same page. I don't want you to get disappointed by the end of this course or by the way that we are covering the guidelines and the exam blueprint. So we will cover majority of the topics that are there in CCNP wireless blueprint, and some of it will align with your expectation, but some of which may not, right? So I just want you guys to have that understanding before we go ahead with this course, right? Anyways, thank you for sharing your experience. And I do understand that you are now trying to become a well-rounded network engineer, probably trying to add wireless as a arsenal in your plethora of technologies that you know. That's great. All right, cool. Who wants to go next?
Hey, hi, Utkarsh. Am I audible?
Yes, you are.
Okay, okay. Hi, this is Nitin, and I have experience of around 12 years. So I have been into routing, switching, and wireless, a little bit of wireless basics like installing of APs and all. Like I have worked on 5500 Cisco wireless controller and few things like I have just researched and done some migration, try to just do some migration from planning from 5500 to 9800 series bus. But I just want to have some basic understanding because, I have an interest in wireless. So I would like to join your class. So just want to know about the how you are going to just provide us from the basics to the expert level, right? So basically, like I have been working in routing, switching, and SD-WAN right now. So, but I would be looking myself to be in wireless as well for like upcoming skills to be added to my career, right? So definitely, like it I hope like it would be a better session with you, like to have a good knowledge with this technology, right?
Absolutely, Nathan. And again, I welcome you to this course
Yeah.
and to this journey. I'm so glad that you decided to jump into wireless as a technology and decided to learn it because
So it is specifically to Cisco Wireless, or it would be to Aruba as well, because I do not have like I have worked, but I do not have much knowledge into Aruba as well. Like,
so this is a Cisco certification, Nathan, right? CCNP wireless, Cisco
okay,
focused. So here we will be discussing some aspects around the design, how
yeah.
to understand the overall portfolio, the wireless portfolio that Cisco has, and how to build a design around it, right?
To
How
be
to
very frank, like I have worked on these technologies, but I never have like uh, get to have some theoretical knowledge. But I have worked on it, so yes, it's a hands-on kind of. I have, but I have never been to the theoretical knowledge. And in my career, whole career, I do not have any kind of knowledge, but I have an hands-on experience.
All right, great, great. Yeah, so here we will cover some basics about the technology itself. Although we will not be doing a very deep dive
Yeah.
into the wireless as a technology, because that's a separate conversation, that's a separate course entirely called
Mhm.
the wireless fundamentals.
Yeah.
But this will be mostly focused around in and around wireless design and deployment, right? And of course, choosing Cisco as our go-to solution.
Yeah, because if I would say, like, as a my study career in graduation, I was being like I have done BTech from electronics and communication. So basically, I have interest into the communication as a wireless. So I have worked into the telecom as well, in the RF as well. So from there itself, I'm getting having interest in this technology basically. So later on, like I have done few courses with the VSAT as well. So GVF, if you heard, Global VSAT Forum. So so in satellite communication basically. So that part, because I'm into the this kind of technology being starting from my career and from the graduation. So I would like to, like, I hope that I will be getting some good knowledge here. Yeah, that is my hope. Like I'll be getting some good stuff from you. Right? Yeah.
I hope that for you, so Nitin, right? So I'm so glad to hear that you do have some experience and understanding of the RF side of things. So maybe one of these sessions you would be able to take it, right? Or maybe I'll lean on you for some of these sessions and basic terminology. But thank you so much for sharing that, Nitin, and welcome.
Thank you. Thank you. Tush.
Hi, Ukas. This is Selva Kumar.
Hey, Selva.
Having overall 10 plus years of experience in networking side. And I have basic hands-on in this wireless actual we are using 9800 catalyst controller there, how to create the tags and how to associate the AP to the controller. Yeah, basic things I have, but coming to the cracking the interview and all, I want to learn more in this. So I decided to join over this course.
Oh,
Yeah, that's it. So whether we are going to look into the Meraki as well, like overview or
so
shared in the demo.
we will touch upon it, Selva, but again, we will not be going quite deep because that
Fine,
is
fine.
covered
Like
in a
I'm just asking,
separate
like
module.
overview.
But definitely, yes,
Yeah,
we
yeah.
will cover the overview of Meraki as a solution. Yeah.
And as you said that you are not going to touch the dribble shooting part, but at least basic things like for any issue, like what are the major issue we are getting into that wireless part. Whether we are going to look into that, or we are not going to touch anything in the dribble shooting side.
Yeah, same concern also. It was mine from my side. Okay, because it may we can extend the session for some classes. If we require to payment, right? Like because why we are
Yeah,
giving
basic
payment, right?
troubleshooting. Yeah,
So
I will.
we can not basic deep dive as well. Why basic? We are in experienced guy, right? So we need a deep dive as well. So if you want, if you have time, then you can extend. Meanwhile, we can check with the networkings. We will pay. Then we can take because if you are building blocks, then you go into the deep dive. then the troubleshooting part will be missed, then it will not work for me, for as well other guy as well, right? Because we are here to learn everything, not for one chunk, and then so you understand my what I'm trying to say.
Right,
Yeah, go ahead.
absolutely. I get your point regarding the troubleshooting. I don't know, was it Selva and who else?
Abhishek, yeah.
Abhishek. So the only challenge with troubleshooting would be that since this will not be a deep dive into the product side of things, right? So we will not be covering each and every feature set of a specific product, say a wireless 9800 controller. So maybe not a deep dive, but we will figure it out, right? As we go along, as we move along in this course, if that is the consensus of the group here that we have, that we do need troubleshooting understanding, then yes, we can. And of course, I'll also have to get in touch with the networkings team, see if that is something that is aligned with the course and the structure. Yeah.
Yeah, I would say we can cover maximum, Utkarsh. Like we can build
Yes.
up some agenda, right? So that we till we cover maximum, right?
See, maximum is infinity.
Yeah, I mean, whatever you think, like it would be like as a building block, we can, study later on because there are some gaps, as I said, right?
Mhm.
So it's better to have,
So
uh, yeah,
So let me ask you and the overall group here, are or any one of you are they going for the CCNP certification as a certification, or because
to
this
be
course when we started we thought that this will be a CCNP course, right? So we will cover all the exam blueprints, but the feedback that I'm getting that probably that's not what you guys are looking for.
To be very frank, from my side, Utkarsh, I would like to have a knowledge basically, whether it's CCNP or CCI. So I would like to have the knowledge. Later on, we will. I believe like we can think of that later, right? I guess from my side, not others, right?
Yeah, from my side as well, because I'm not into the track to the certification, but I
Sure.
get a knowledge into that, and at least to crack the interview, and I want to implement this in the my current project as well. So they are using the 9800 catalyst controller. So what are the issues we will face? So that's the reason we jump over here.
Okay.
Yeah, this is all from my end, Lucas. Thank you.
Thank you. Thanks, Selva. Anyone out of the group by show of hands, or if anyone wants to unmute and speak up, anyone else who is preparing for CCNP wireless? Because we do have to take the consensus of the group and then, of course, the networking team. So, and based on that, we will decide the agenda, right? I just don't want to throw all the theory and which will not be useful and which will not add value to this group. So I would want to be mindful of that fact. So, by show
From
of
the
hands, anyone who's
not from the
waiting
exam
for.
point of view, Utkarsh, for the knowledge point of view, because we see in the organization, lot
Mhm.
of people are not certified wireless,
Right.
but they know the knowledge of at packet level. They know the how to implement, how to troubleshoot. So main
Mhm.
concept and main point is concept and knowledge.
Okay. Okay. Cool. Thank
But
you.
I believe we should have labs to have it more clear, right? Because that would help us to just understand the
Mm,
concept better, right?
no, Nathan, we don't have lab. I have already raised this
Okay.
concern with
Yeah,
team.
unfortunately, there is some limitation based on the infrastructure side of things,
Yeah,
right? We
whatever the
do not
best we
have
can do. Yeah.
labs, but I will
Hmm.
do some live demos with the lab
Okay.
that I have,
Yeah, yeah, sure.
right? So we can do certainly that.
No problem. Utkarsh. Yeah, whatever best we can do. Yes. Thanks.
Okay. All right. Um, anyone
Okay,
else?
so
Anyone
yes,
else?
okay. So, of course, myself is Ravinder. So, I have a 13 year of experience in routing, switching, and 7 year of experience in wireless. 2 years in Aruba and 5 years in Cisco,
Oh, wow.
and big IP, F5, SD-WAN, Cisco, and VMware's Azure 104, and my role and responsibility is to implement and deploy the project as a senior consultant in the organization. So in that position, we have a single point of contact. You have to deploy everything, whether it's a firewall, router, switch, SD-WAN, wireless. So you have to deploy everything. So we know how to deploy the wireless 9800s and AP. But sometimes there is a gap like 10%, 20% from the concept point of view. In last 4 days, I am troubleshooting the issue AP is not showing the 9800 WLC. So we take the console and check the logs. So there is an option 43 in DSCP, and hex value is not defined by the DSCP guys. So basic concept, if we are going to implement or troubleshoot the wireless, so first of all we need to clear where is the exact issue. It's a wireless issue, it's a DSCP issue, or it's a routing switching issue. So first of all we need to know so that we can include the particular team. Say this is not our issue, this is your issue. Say admin team, please look into DSCP servers. So
Got
that point of view we need to clear.
Got it, Ravinder. So I think again you fully align with the other guys that have spoken before you. So it looks like that the gaps that we have currently in our skill set is basically the understanding of the wireless and how it fits in overall piece of the infrastructure side of things, right? So I'm assuming that's what you as well as the other people who have just spoken before they want to go for. And really, you guys are not looking to clear the CCNP exam, the CCNP wireless exam. That's not the goal or the agenda that you have, right?
Right.
So for managing day-to-day operations for wireless, deploying wireless, designing wireless is
Right.
something that you
Correct.
are looking at.
Exactly. Yeah.
Correct. Exactly.
Exactly,
Yes.
exactly. Yeah, Kutz, yeah.
Because sometimes if we are troubleshooting the issue, suppose wireless is not working, and from our end we clear, see this is not wireless issue, and tomorrow it's a wireless issue, so it's not a good picture. So it must be clear from our end. See, we are clear from the wireless, it's not wireless issue. Maybe it's a DSCP issue or some other issue or ICE, Cisco ICE issue. That's the
Yeah.
point.
We are limited to some scope of work, so from end to end we can able to just find out what exactly the issue is, so that we
Yes.
can confidently say that it's a that team issue or it's issue or on our end, right? Yeah.
Okay. Okay. And how about the understanding on the RF side of the things, right? So deploying is one thing, right? So you know how to configure, or at least some of you know how to configure the tags, how to create, or at least make the AP join the controller, right? So that's one thing. But when it comes to troubleshooting, having an understanding of the RF side of the things is also important, right? So how about that? I know that one of you, I'm sorry, I forget the name, they do have the understanding of the RF side of things. I think in his graduation, he did some courses around the RF, but
But yeah, Utkarsh, it's me, Nitin.
Nitin, yeah,
So yeah, so in satellite we have different frequencies of things, right? So
right.
basically, I would like to know here in wireless what kind of frequencies bands we are using, right? Apart from gradually going into the concept of like attaching the APs, because I was working configuring the APs as a standalone. Later on we are having the technology of lightweight APs, then which we are integrating it with the controllers, right, with the cap web tunnels.
Mhm.
So I know the cap web tunnels, but I have studied few things like how cap web works actually in depth. Basically, I would like to understand, right?
Mhm.
So there are much more methods,
Right.
like right, so remotely and locally, what is the difference in that, you know this
Mhm.
kind of concept I have a gap, because the things, eventually we are able to latch the APs and configure the APs, but we actually do not know what is happening on the background
Right.
actually.
And if
Yeah,
something breaks, maybe
yeah,
we're
yeah.
not in a position to quickly
Right,
identify
right.
and isolate. Yeah.
Right.
Correct,
AP
correct,
is
correct.
in right position or not. They are getting the right signal, or how we can increase regarding the heat map.
Yeah.
These kind of
So
details.
few
And
few few troubleshooting, like I have just rectified on my own, like some frequency reuse issue, right?
Mhm.
So there, if there is some channels issues right there, so we need to decrease the channels, and right. So looking after the heat maps, how we build, what are the parameters of building the heat maps? We should know that, like how frequency cannot be reused, interference should not be there. You know so
uh,
yeah, so
and
those basic concepts basically we would like to know.
Mhm.
So we would have some perfect knowledge. It's not about the certifications, right?
Absolutely.
Yeah.
And sometime if we join the 2.5 gigahertz band, not 5 gigahertz
Yeah.
band, what is the reason why they are not joining 5 gigahertz band, whether it's
So
enabled or not?
yeah,
And
so
another,
basic regions, like we have understanding like frequency. If it is less, it would have more wavelength, you know. So those kind of basic knowledge we have, but you know, specifically how things works, so that we would like to know, because yeah, so in telecom sector which we have a knowledge is like one to one,
Correct.
like telecom sector is having like one to one, like we have ODUs, right, outdoor units in telecoms, right? So they have to just different frequencies and bands, so that is something different actually.
Absolutely.
Telecom is different, satellite communication is different, and I have worked in broadcast industries as well. So they have some different frequencies, right? Like in channels, basically, if you see, yeah,
Not just the frequency, but the
yeah,
overall standards and the protocols that they use.
yeah, yes,
Entirely
yes,
different.
right, sir,
So
right, sir,
the way that the devices will communicate and try and
yeah,
establish the network, that's completely different in all these technologies.
yes, yes,
right, and when we face any issue like we define the site tag, policy tag, and location, all this, so we have to isolate the issue. So that could be the site tag issue, this could be the policy tag issue, so that we are aware if we are
yeah.
facing this issue.
And there are some packages as well. We build up like silver and bronze. What are those like? So
The,
I don't,
the
yeah,
quality of services, metal.
qualities and QS, yeah.
Okay. 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 I think I'm getting a fair understanding and the requirement from this group that we have here. Right. So far, it is pretty clear that none of you are looking to clear the CCNP certification,
Right.
and um, we will have to tweak the agenda then, right? Because I don't really want to give out just the theory and then be done with it. Say goodbye, tata, bye bye, right? Uh,
Yeah.
I'm here to add value. Hopefully, with my experience, I can add some values in your skill gap. So that's the main agenda from my end, at least. Right. So I will have to reconvene with the networking team, see how can we maybe build up an agenda around it. Because initially, when we began these classes, or at least started advertising these classes, these were supposed to be a CCNP wireless focused program, right? So where we go through each module of CCNP wireless, including the design and the core part of the new CCNP wireless, right?
Yeah, one more thing, like guys, everybody know like what is the course content, right? We have shared everything in the course content. So right now, from the start, let's stick to that because we have discussed with Utkarsh and we have already conveyed each and everything, like each concepts and course content is visible to each student who have enrolled for this course, right? So right now, let's stick to it. Okay, Utkarsh, you can go ahead. Thank you.
All right, cool. So what we'll do, guys, here is that we will start with some of the basics, and I hope that should address majority of your, at least from the wireless basics understanding point of view, it should help you fill that gap, and from there we will go on, build upon those, and see where we can, or which section or which module we want to cover, or which we can leave out if it's something that doesn't add value.
Adding to this, Kash, if we have some understanding with the integration of ICE with the wireless
Mhm.
and some basic Meraki and Aruba concepts.
Mm.
It's product to product, but you know, basic we can cover
Yeah, at least basics definitely we can.
so that we can research it later. So if we have a good base, right? So that we can later on study and yeah, everything. Of course, everything is not possible to cover up, right? But
Absolutely. Yeah. I know because all of us will come with a different expectation to any of these courses, right? Some of us will have a different understanding, maybe in the skill set, somebody will be on a higher level, maybe somebody on a lower level. So catering to everyone maybe will not be possible, right? I hope that's practically not possible, but we will find a common ground definitely, right? And from there we will start our journey.
yeah, thank you, Akash.
Utkarsh, I have a expectation like as I don't have any expertise on the wireless basic concepts like what is RF, what is channel, what is DVI, I don't know. So I was expecting that the course will help me going through the content. So I believe I'm not wrong. Please correct me if I'm wrong.
Right. So even as a part of CCNP wireless module, right? So there is a module within the core exam, the new core exam that you may have seen coming up. That module does have some aspects of the RF, some aspects of the RF math, right? What is DB? What's RSSI? What is it? SNR? What's their relevance in overall wireless connectivity? So we are going to cover that. But again, just keep in mind that this is again a very wide topic. There is a specific course called Wireless Fundamentals that's defined, and there is an exam blueprint for that as well, defined by Cisco. That again runs for about 40 hours or so, and that does a quite in-depth deep dive into the wireless. So we are not going to go into that level of details, but again, to your point, we definitely will cover at least the building blocks of wireless, which includes what's frequency, what's wavelength, what is RF actually, right? And why do we need to care about RF when we are talking about wireless? So yeah, we will cover some aspects of it.
Thank you.
Absolutely. All right. Anyone else who has any different expectation or want to go next?
Hi, Utkarsh. This is Gulzar.
Hey, Gulzar.
So I have a total 5.5 years of experience in
Mhm.
switching. And primarily, I'm working as Cisco ICE engineer,
Mhm.
and also I'm working on firewall. And recently, we have been handed over with wireless operations.
Oh,
So yeah, so so right now I'm in problem. There are many things going on in wireless, and I need your help. So my expectations are, like I don't have to configure from scratch, WLC or anything. But I should be knowing how it is done, and right from the deployment, configuration, and mostly the operations part, like how everything connects, right? WLC, AP, cap app, tunnel, Cisco eyes, how wireless, as you said, how wireless fits in the puzzle, in the complete infrastructure. So yeah, so basically it should help me in managing wireless operations, and also I should be having good knowledge on configuration as well.
great. Thank you for sharing your experience and the context that you bring in, Gulzar. And I'm so glad that, I mean, for whatever reasons that this additional responsibilities has been thrown to you, but hopefully this will kick off your wireless journey and add that skill into your, repertoire of skills. So I'm glad that you're here. Thank you.
Thanks, Utkarsh.
All right. Cool. So what we will do today is, if I don't know if I left out somebody, if somebody wants to go before we, start some of the agenda actually for today. Because again, today I just wanted to keep it light. It was mostly a conversation that we are going to have today, right? And then maybe just pick up one skill, at least one basic concept around the wireless. I think if that is something that we are able to understand by the end of this session, that would be good enough for me. So anyone else wants to go say hi, hello, anything?
So before we start, Utkarsh, I would like to know about the career in wireless. Any comments and anything you would suggest?
Sorry, repeat that again.
Okay, so I'm audible.
Yes, you are. Yep.
Okay. So, Utkarsh, like I would like to know about the career. What do you think about like wireless future, and what would you say your comments? Something like what would you say? Like, yeah.
Thank you. Thank you for asking that question. I was hoping that somebody
And
would
and
answer.
and sorry for disturbing. Also add AI aspect as well. What they will change in our life. Okay.
Oh man, these are
Yeah.
loaded questions. Thank you.
Yeah.
You guys
Because
put
today license, so that's why I want to take a liberty.
no,
That's
absolutely.
how everybody will be excited to know, right?
Exactly. These are very valid questions given the times that we are in, right? And of course, since this is a professional course, so we would want to know whether or not this will add any value to our professional career, right? So, Nitin, thank you for asking that question. So, from the perspective of growth, Nitin, I would say that I mean, see, from my perspective, I am in this industry for about close to 14 years now, right? So I started back when we were just beginning to understand 802.11n, right? And now we are in the day and age of Wi-Fi 7, which is almost being rolled out in all the organizations now. Within next 2 to 3 years, we will be transitioning to Wi-Fi 8. So as you can imagine that even in our homes and even in our offices, we have the wireless first as an approach to connect to the networks, right? So barely you will find any organization that still relies on the wired connectivity. And it's just that the number of devices is only growing. The demand is only growing for faster, better, and available everywhere wireless connectivity, right? So, I mean, it's almost as if that we expect wireless wherever on whichever building that we walk in, and not just the expectation that the wireless connectivity is available, but also the wireless is pretty stable, right? Even I mean, if I pull up my phone and there is even a slight lag in opening up a page or an app, man, I get frustrated, right? And that's the expectation that, or not the expectation, but that's the baseline that everyone now has. And this is not in just the terms of the data connectivity. Now, even the critical pieces of the infrastructure and the businesses which used to rely heavily on the wired infrastructure, now they have begun to transition on the wireless infrastructure as well, right? Think of the use cases of warehouses where you have millions and billions of shipments that are going out every month, every year. Those guys also rely on wireless connectivity to quickly scan, to locate inventory, to fill up their inventory details, to keep a track of inventory. Hospitality, airports, hotels, right? You expect the greatest and the latest Wi-Fi to be available for you as soon as you step in the premises. Think of hospitals. Some of the patient monitoring systems, they are now wireless, right? And in some cases, they are actually life and death situations where you want all these critical sensors devices to be available onto the wireless network for real-time reporting, real-time monitoring. um, think of stadiums. Even stadiums now have Wi-Fi connectivity, right? So if you are there as a fan, going in there as a fan, watching a cricket match or a football match or whatever, you expect Wi-Fi to be there. I mean, I personally am also involved in deploying these kind of deployments, be it stadiums, be it cruise ships, right? Out in the sea, you still want to stream Netflix. I mean, that's the expectation that everybody now has. So I can only see there is a future demand. I do not see it slowing down anytime soon, right? The demand is only going to grow as and when we transition into the newer Wi-Fi standards. So from the career perspective, yeah, today is the best time to be in Wi-Fi. Tomorrow will be even a better time to be in Wi-Fi. And if you are today already transitioning into a career of wireless, you will be placed better than any of the other guys who are starting a little late, right? Because you have that buildup of the technology. Now, coming to the second point of the question regarding the AI. Well, AI, as you can imagine, it has changed the way that we are working day in, day out. I mean, if you look at the stats, right? Recently, I read a report where majority of the users, if not majority, but close to majority of the users, now go to Chat GPT as their first search options, right? They don't want to open Google and do a search. They ask Chat GPT. So it's only fair to assume that AI is going to change the way that we work. And wireless is not an exception. And I'm pretty sure that even in your day-to-day jobs and day-to-day roles within the network side of the things, you would have seen how AI is becoming an important part of the conversation, at least as of today. But if you look at tomorrow, AI is getting integrated in terms of how do you monitor the network? How can you be more proactive in hopefully before getting any end user reports of any disruption? Proactively, you are able to flag those potential issues, and hopefully with the help of AI, solve those issues as well. So AI is not going to disrupt our roles in a major fashion, but it may disrupt the way that we work, right? So we will still need network engineers. We will still need good expert level network engineers, because if anything goes south, network engineers will be the one who are going to be blamed, right? Even if it's an application issue or whatever, yeah, it's always network. So if I heard somebody had some experience with Meraki and some experience with Cisco 9800 controllers as well. So with Meraki, with Cisco 9800 controllers, and with the Cisco Catalyst Center, there is a strong integration of AI ops as of today, right? So there are a lot of features, there are a lot of modules within Catalyst Center, within Meraki dashboard that you can leverage as of today to monitor, to analyze, to get more insights out of your network. And hopefully with those insights, you will be in a better position to troubleshoot, quickly troubleshoot and identify then any potential issues. So I'm not sure if I answered the questions. It was pretty long answer for a short question, but I just wanted to cover majority of the aspects that I see personally as a network architect, wireless consultant, see how the times are changing and where should we shift our focus on. Just a side note though, that although we know that AI is becoming very integral part of the network operations as of today, uh, and we are slowly even shifting from the days, maybe just 3-4 years back, where there was a huge shift that when it was expected out of a network engineer that a network engineer should at least know how to interpret Python scripts, or at least write some Python script, basic Python scripts. Now we have moved over because majority of the things have been taken care by the AI modules that most of the companies are building into their product. So in some aspects, you may not actually need to write scripts in order to automate, because some of it is already there, but you should have some understanding of it and how it works, because ultimately if things break, yeah, you are the one who is going to get your hands dirty. Yeah, that's my take.
Yeah,
So
thank you.
one
Thank you so
question
much.
from yeah. So one question from my side, like so the evolution of Wi-Fi, the same way like the evolution of RF is also going booming like anything, right? Like for example,
Evolution of RF.
RF, like in the sense like satellite communication now, Starlink is there in outside US, so they are using Starlink connectivity instead of connecting directly to the laptops, desktops, and however it is. So, so how this will impact, or is it going to be a I know that it won't be constant or stable compared to the Wi-Fi, whatever it is, like currently we are using it. But do you have anything on that?
So satellite communication, Sanjeev, is a different aspect, right? So with Wi-Fi, we are dealing with the LAN environment, where
Yeah,
satellite communication comes or tries to be an alternate service provider, right? If there is an ISP
correct.
that's providing the services, the connectivity, the internet links to a business or to an organization, Starlink can do that to provide an uplink connectivity to that organization as an alternate. So in my experience, I've seen that as of today, as you rightly called out, there are two factors that impact Starlink. One is, of course, pretty high costs as of today. And the second thing is, as of this moment, we do not have that level of bandwidth available with Starlink. So some of the organizations where they have very critical infrastructure at some of the regions, they use Starlink as a backup ISP for them. Right? So in case if there is any disaster that happens and their primary ISP goes down for whatever reasons, they, at least for their critical operations, they rely on Starlink. But Starlink is not going to compete in the same space as Wi-Fi. So Wi-Fi comes after ISP, right? So once you have the connection, it's mostly a Wi-Fi is giving you the entry point into the network. While Starlink comes into the picture once you gain an entry point into the network, and now you want to move out of the network, go into the internet, or go over the WAN link to your other location HQ or whatever. So Starlink plays in that zone, not with Wi-Fi. So it does not directly compete with Wi-Fi.
Okay.
Because I have worked for like one of the oil and gas industry. So basically, they are working in this ship basically. So they are using reset, and of course, you said like it's very costly, right? So what I mean to say is like they were using like 512K bandwidth, and which is cost them very high. So if we are just configuring the whole comms kit out there, including routers, switch, Wi-Fi APs, right? So my question is, like in that limited bandwidth, right? So how, what is the solution we are providing from Wi-Fi side to just, optimize the bandwidth? So obviously we are using QoS, right? So would like to know about the difference between Wi-Fi 6 and Wi-Fi 8, what you are saying, like, and whatever the technology earlier we were using. So what are the basic difference in that? In real, as you said, real time scenario, right? Real time streaming, if we can say, in football match, right? FIFA match, right? So we need a seamless connectivity, right? So what we mean by that technically, right? In Wi-Fi 6 or Wi-Fi 8, what are the concepts around that, so that we were having a real time, without any glitch in a video, or real time, without any delay or latency, apart from the bandwidth and the cost effective solution to be provided from the, every customer need a cost effective solution. Nobody wants to just invest in the bandwidth, right? So what in the Wi-Fi, what technology basically we are going to use, and what concept or designing part we are going to use? We just want to know more into depth, like, from you.
Sure, sure. So from the cost-effective terms, see, it really depends on what are we trying to achieve. Because as you rightly called out, that these VSATs and Starlinks are quite costly, right? So you can't have them as your primary, or you can't offload everything on there, on those links, on those uplinks. Now, it really depends on the requirements, and it changes drastically business to business. Some of the businesses treat their operations, manufacturing, as their critical operations, while for some of them, in case in point, in hospitality, a user experience for guests coming in is quite critical. So based on that criticality, there is a decision that gets taken, and based on those decisions, based on those requirements, you choose what is the optimal solution that you can propose. Again, there is no cookie cutter solution that you can propose to everyone, each and every client, each and every customer, because everyone is different, everyone has a different understanding and different requirements. So it really depends on the requirements. Unfortunately, I do not have a straight answer to you. And again, I'm not trying to be diplomatic. It's just the way that it really works, right? So even in my day-to-day job, right? So my job as a wireless architect, as a wireless consultant, is actually to do exactly what you called out. So my job is, I come into the picture when sales team is trying to sell a solution to the customer, and I try and come in and understand what is the requirement of that particular customer, how our solution fits their requirement, and out of our overall portfolio, which solutions will meet their exact needs. So we do a deep dive with them. We go into requirement gathering sessions with them, try and understand, and then we build a overall solution.
Yeah, so there is some limitations maybe from the QoS side also. We can limitize up to some extent, but we should also give some requirement to the customer that how much bandwidth we need, right? That's what I just want to understand from you, right?
Absolutely.
Yeah, that's what I got from.
Yeah, exactly. So customers should also understand the limitations of the technology, and we should also understand the requirement of the customer, and then try and meet somewhere in the middle to build that solution. So be it from the perspective of QoS, be it from the perspective of choosing which model of access point they want to deploy, which model of controllers they want to deploy, whether on-prem would make more sense for them, or a cloud solution will make more sense to them. So yeah, different factors will impact.
Would really be happy if you can take some scenarios in that way, so that we can in future would like to work with pre-sales and all that, right? So it would be having some good understanding if you just share some knowledge regarding that as a part of design.
Absolutely, absolutely. I'll do that. Thank you.
And same is it occurs like security concern, like in WLC we are using WPA2, and now we have WPA3. So in our organization they are moving to WPA3. So what are the requirement? What are the endpoint which support WPA3? So we need to identify and then how we can fix it and what we can suggest to the client.
Okay. Yeah. We can definitely cover that, some aspects of it, right? So, because security is important for wireless, so definitely we will have a conversation about the security piece of the wireless. So it will include .1x, WPA2, WPA3. What's the difference between these? So yeah, we will cover some basics of it. Yeah.
Okay.
And some cloud infrastructure as well, Utkarsh, how we are just migrating towards cloud, some brief.
Yes, so we will cover the we will start with the overall portfolio of Cisco, right? And specifically around, in and around wireless. And since we have cloud products as well available, so we will touch upon it.
Okay, thank you so much.
Thank you. All right. So what I was planning to do is, I think we are almost coming close to our today's session. We couldn't really start any topic, but I would at least start to maybe spend next 15 minutes or so just to lay a basic foundation of wireless, so that when we meet next after Diwali, we will start from there. Yeah.
Sure. So class will be it's 2 hours, 9 to 11.
It's 9 to 10,
1 hour.
It will be weekly or weekend?
Monday to Friday.
On weekdays. And
Weekdays.
days in a week,
Okay.
I'll share. You all are part of group. I'll post it there.
Yeah, schedule will be provided to you on what days we are trying to work, but this is on weekdays and 9 to 10. Okay. All right. So with that, let me share my screen. Okay. Are you guys able to see my screen?
Yeah.
Yes, Utkarsh. Yeah.
Okay. Are you seeing the web browser? I don't know which screen I'm sharing. It's getting a little confusing.
Yeah, it's paint, something like
Yeah.
paint.
It's a blackboard.
Okay. Blackboard. Cool. Thank you. Yeah, that's what I intended to share. Okay. Great. So since we do not have much time left today, and actually this is good that we spent this time having conversation around the expectation about this course. So this was time well spent, so don't worry, right? But as far as the technical concept and the technical topic that's concerned, I was planning to cover at least one basic topic for today, right? And that's mostly to do around the RF side, not from the solution side, not from what product portfolio we have with Cisco, because that will come into later. But for today, I wanted to talk about the Wi-Fi as a technology itself. Right now, before we move and deep dive into the Wi-Fi technology, there is some correlation of Wi-Fi with light. And by light, I mean the actual light that we see, right? So for example, in my room, I have a light that switch on so that you guys can see me. So I mean that light. So for some of you, this may be very rudimentary, but for some of us, we want to use this opportunity to build our basics, right? So Wi-Fi is a form of light, right? It's a sort of a controversial statement that I just made when I said that Wi-Fi is a form of light, and we will build upon it a little later. But as of right now, think of that Wi-Fi is actually a form of light. Although it is not the visible light that we see here. Oops, sorry, I lost my pen. You guys can still see the blackboard, yeah?
Yeah.
Okay.
Yes.
Sorry, I just had a pop-up on my PC saying that screen sharing got stopped for a while. Give me 1 second. I don't know where the pop-up went. Oh, there you go. Okay. Cool. Okay. All right. So what I was trying to explain is that this light that we are talking about is not actually the visible kind of light that we see from a lamp or a sun for that matter, but this is what we are talking about are the electromagnetic spectrum. Now, some of you, as I understand, have some understanding of the electromagnetic spectrum because some of you have worked in that technology, if not Wi-Fi, but in the electromagnetic spectrum technology itself. And Wi-Fi is a small chunk, is a small part of that entire spectrum. And this means that the access points and the wireless devices and the wireless clients, or in fact, any other type of wireless device that we use, which utilizes Wi-Fi as a medium to connect to the wireless network, is actually using an invisible light waves to communicate. Now, this is very different if you talk about the Ethernet world, the wired world in networking, where we use cables, Ethernet cables, fiber cables, in order to provide the connectivity, connect our endpoints, laptops, or other network devices with each other. And as in the case with the wired side of the things with the cable, the main intent of the cable is to provide that last mile of connectivity to you as a user. If I'm using a desktop or a laptop which is connected to a wired switch, right? That's the last mile of connectivity from that perspective. And also, if you go a little deep, essentially that cable is converting the electrical signals into ones and zeros and then transmitting it over, right? Or the other way around. Our computers are working on ones and zeros, and then it gets converted into electrical signals, and these cables, the Ethernet cables, use those signals in order to transmit those bits of information to the other end. And if you replace that with a fiber optic cable, it almost does the similar job, but instead of an electrical signal, it uses a light signal. And that's why it's called optical fiber, right? So there, within that cable, you have a bouncing light, if you will, which is sent across to the other end. And on the other end, it is interpreted and then it gets converted back into bits, ones and zeros. And the other PC or the other device, which is on the other end, is able to understand what the other device has sent. Now, here in wireless, since we do not have those cables, we do not have optical fibers or Ethernet cables, we rely on this light, the invisible light, in order to send the information over to the other side. Now, since we are utilizing light as a medium of communication instead of the wired, instead of the physical wires, we need to understand some aspects of the light itself in order to understand how the overall communication can get impacted due to this behavior of light, right? And you can think of in terms of light as invisible light as well. So if you switch on a flashlight or a torch and flash it on a dark room, right, you see sort of a beam that's spreading out from your flashlight, right? And then on the other end of the wall, you see a good amount of light, and using that light, you can easily see if it's a dark room. Now, if you have that understanding of the behavior of the light, where you know that, hey, if I point my flashlight in this particular direction, I'm going to get light only in this direction. If I move over to the other wall or the opposite wall, I will able to see anything on the other wall, right? So you understand that mechanics, that physics of a visible light, because it's quite intuitive because you can see it. But with Wi-Fi, since we are utilizing a portion of the visible of the electromagnetic spectrum which is not visible at all, it becomes little hard to visualize it, that how it behaves. So it's important for us to understand and break down the behavior of this light so that we understand in different conditions how will it behave, because eventually this behavior will impact our wireless devices or the end user experience. For example, since most of you have some understanding of the wireless, if you walk into a room full of wireless devices, full of people having maybe 2 or 3 Wi-Fi devices, and it's a pretty packed room, pretty small room, you will quickly understand without even opening and testing your device that, hey, I'm not going to get good speeds here, right? Because there is a congestion, because everyone is competing in this room to get a piece of this RF, this air, in order to communicate, because everybody wants to send data, everybody wants to receive data in that room. So you have that understanding. But it also impacts in terms of the overall deployment of the wireless networks, how is a particular deployment or a campus is. So if it has maybe glass walls, if they have very large hallways, if it's a warehouse with huge ceilings and they have these metal racks lined up, all these will impact the way your wireless signals will propagate. Right? So it's quite important for us as Wi-Fi engineers, as wireless designers, to understand this aspect of wireless. Right? And that's why I wanted to break it down to a very minute piece where we talk about Wi-Fi as a light. Again, I said that this is controversial because Wi-Fi is not actually a light. It just uses that light in order to transmit the data. But hopefully you get the point. Right. And there is a fun fact that probably I would want to call out, and hopefully you guys have heard of a technology called Li-Fi, right? It utilizes the visible light. Just like Wi-Fi utilizes an invisible light, there is a technology called Li-Fi, although the applications are quite limited, but there is a standard technology defined by IEEE called Li-Fi, which works on a visible light. That's just a fun fact. Now, coming back to our original question or original discussion. Sorry, was there a question? Okay. I thought I heard something. Okay. Now, before we discuss the major aspects of the light, I would also want to maybe just quickly standardize the understanding that the light that we are talking about here is actually the waveform of a light. Oops, sorry. That's a pretty bad wave. But consider that this is a wave. And by wave, I mean mathematically, you can represent the visible spectrum as well as the invisible spectrum of a light as a sinusoidal wave or a sine wave or a sine curve, right? And you can also think and imagine this wave not only with Wi-Fi, but you can also imagine this wave as a sound wave, because that's also the electromagnetic spectrum. It also lies in the electromagnetic spectrum. You can also visualize the waves as if you are dropping maybe a pebble in a still water, maybe a pond or even in a bucket, right? So if you drop a pebble in a bucket or a still water, it sort of creates a ripple effect, right? It creates these waves around it if you drop it in the center, and it goes further and further apart. So those are also waves. So you can think of Wi-Fi in something of that similar fashion, where we have mathematically represented these waves, the electromagnetic spectrum, in waves, in waveform, as a sine wave or a sine curve. Now, since we are talking about the wave as a very basic fundamental unit of the mode which Wi-Fi technology uses in order to send and receive data, it is important for us to understand few basic terminology, right? So consider that this is one sine wave, right? Now, this sine wave have few specific characteristics where we define the highest point of a wave, maybe this guy, as a crest. And this is something that we may have all read in back in our schools and physics lessons. And the lowest point of a wave is known as a trough. And if you were to draw a line in the middle of this wave, this line is known as the origin. I'm sorry for my bad writing, but hopefully you are able to make it out. Right? So we have origin, which is the center point of a wave. You have the crest, which is the highest point of a wave. And then you have a trough, which is the lowest point of a wave. Now, this center line or this origin is quite important because this is the center line where your overall wave will oscillate around, right? And then there is another terminology that we should be aware of, or another characteristic that we should be aware of, is the amplitude. Now, this amplitude is actually the physical distance from the origin point to either crest or trough, right? So it can be measured in either of the direction. It's not only in the highest point, but it can also measured in this direction as well. So amplitude, as I said, that it refers to the height of this wave from the origin. So it's not actually the complete height from the crest to the trough. It's not this height, it's this height, either from crest, either from origin to crest or from origin to trough, right? Now, taking this slightly forward, let me maybe choose a different color so that it is a little clear. Okay. Taking this one step forward, right? We also want to know about something known as a period of a wave or a waveform. Now, period essentially is the time that it takes to complete one full cycle, which goes up and down and back to the same starting point. So for example, for this particular wave, the starting point was this. So it went up to the crest. It went back to the lowest point, which is the trough. And then it came back to the origin, right? So this entire this entire time period where the waveform started from the origin, went to its highest point, came back to went down to the lowest point, and then came back to the origin. This time that this entire waveform took in order to complete this cycle is known as the period, right? And this is called as one complete cycle, right? Where it starts from the origin, goes to the crest, back to the trough, and then back to the origin. This is called as one full cycle of a wave, and the time it takes to complete this full cycle is known as a period. Now, these are very fundamental blocks of a wave where before we start transitioning into the Wi-Fi, but I just wanted to ensure that we all have this understanding before we move forward. So any questions around it? Again, this is pretty basic terminology. We may have read about all these terminologies, but we tend to forget if we don't use it day in, day out. But we should remember that these are some of the basic characteristics of a wave. So any questions around it? Okay, cool. All right. So one last thing maybe we will quickly discuss before we end today's session is, sorry, maybe I'll just scroll down, is an interesting concept called, oops, not this. And I'm pretty sure Nitin may have heard of it, right, Nitin? Phase. I was just about to mention phase. Right, since you may have worked into different technologies, although not Wi-Fi, but at least some of it. Okay. So I'm just trying to see if I can do this. Oh yeah, I can. Okay, this is cool. All right. So sometimes there are two waves with the exact same shape and size, right? Just like what we have drawn here. Although this is not perfect sine wave, but think of it as a perfect smooth sine wave that, you have smooth curve and then the same crest and the same trough, right? So although it, as of right now, it looks that it goes a little deeper as it goes higher, but yeah, the crest and the trough distance from the origin, consider it to be the same. Now, when you're trying to compare two different waves, right? So imagine there are two different sources from which the wave has originated. Now, if both the sources have exactly the same shape and size of this wave that they are emitting, and oops, sorry, can I still use this? Yeah, okay. So if they have exactly the same shape and size, they will align with each other perfectly, right? So that it's sort of superimposed to one another. So, I mean, even so that you are unable to make any difference out of it. Now, what happens if maybe this wave starts a little after the first wave? So consider the yellow wave as our base or a reference wave and the blue wave as the new wave from a second source. Now, what if this guy starts somewhere in this point, maybe after some time, for example, after wave one? So I'll just mark it as wave one, and this wave two is the blue guy. Now, if it starts somewhere here and it did not align it perfectly, but let me see if it does. Oops. Yeah. How about somewhere here, right? And there is a reason why I dragged it here, because I wanted to overlay when phase or wave one has hit its highest point, which is crest, then this guy is starting, right? You can see that the starting point of the blue wave is when the yellow wave has already reached its highest point, the crest. Now, these two waves are now said to be 90-degree out of phase. And in the first case, when both the waves were overlapping exactly the same, where both the starting point was same and they both had the same crest, they both had the same trough, they were said to be in 0-degree phase difference. Now you can also have different phases. For example, one is 90-degree. You can probably have 180-degree out of phase waves as well, where sorry, where this guy will maybe start. Oops, sorry. Oh, it's moving both of them. Okay, yeah. So this guy, the blue wave, will now start maybe after completely 180 degrees, where sorry, I still there you go, where so the second wave will start when the yellow wave has already reached its crest, and then it is back to the origin point. Now if the wave has started, it is now said to be 180-degree out of phase, right? Because it may cancel out each other. Again, this is not a perfect sine wave that I have drawn, but if it were a perfect wave, this crest of the first wave will completely align with the this trough of the first wave will completely align with the crest of the second wave. So it may cancel each other out. So there are few different phases that we should be aware of, or the phase difference that we should be aware of. One is, of course, the 0-degree, where everything is same, the starting point, the crest, the trough, everything, the shape and size, of course. And then we have 90-degree, when we have a 90-degree phase shift, and then 180-degree. Now, this is important for us to understand as a building block, although you will not even care about this when you're dealing with and troubleshooting day in, day out wireless, because it's already inbuilt into the technology itself as the standard itself. But again, this will serve as a building block when we we'll talk about some aspects of the standards as standards altogether, right? So 802.11n, AX, BE, whatever. So there is a specific use case where we will talk about the phase. So that's why it is important for us, at least at this point, just to have a vague idea what do we mean by these phase difference, right? And any questions around it? I know this is mostly on the little heavy on the physics side of the things. Again, we are not going to deep dive into the physics of the light, but these are some of the basic building blocks that is important for us. All right, cool.
So what is the meaning of this line mm, phase?
So as I said that right now we just need to remember two things, right? When we talk about two different, because remember that we said that Wi-Fi is eventually using these light waves in order to communicate, send and receive data, right? Now Wi-Fi, I mean, in an overall Wi-Fi infrastructure, you will have multiple devices, right? You have a laptop, you have phones, you have iPads, you have sensors, you have access points. So all of these devices are emitting and receiving these waves continuously, right?
Okay.
Right? So some of these waves potentially may cancel each other out when they are being transmitted and being received over the same space. If I'm in this particular room and I have 40 devices in this room and every device is trying to send these waves or receive these waves, there is a chance that these waves will collide.
Okay. So is it
And
overlapping? You mean to understand us? It is overlapping here.
it is, it is. So,
Okay.
there are high chances that it may collide. There are high chances that they may cancel each other out. Right? And that will translate into a bad user experience. You will see that on my device, I'm getting huge latency. I'm unable to open applications, or there is a lag in my videos, right? So this has a potential impact on the end user experience,
Okay.
right?
Okay.
Now, the reason that we are talking about these waves and the phase difference is because it plays an important role in some of the standards. When we
Okay.
will eventually in next few sessions, when we will talk about the 11n standard as compared to 802.11b standard, you will see these phase come into picture because there is a specific technology that was introduced in 11n that uses this specific thing in order to, have a better user experience. Although
So
you
is this measured? Phase is measured in by some any tool?
So as a Wi-Fi engineers, we don't really need to measure it because
Okay.
there are different parameters that for us, which will be important. So these are measured when you're strictly talking about the physics sides of the things, right? So when you are actually analyzing the wave itself, then you are analyzing these phase differences. Then you will
Okay.
want to know why this one wave is out of phase as compared to another, or what caused the cancellation of my original signal, whether it was the signal that I received, was it out of phase and that's why it was cancelled out. But for us, we don't really need to worry in our day-to-day operations.
Okay.
This is mostly
So
on the
in the site survey, is it required to
no.
measure this or something that in the site survey? No.
No, not at all. Not at all.
Okay.
So
Okay.
on site survey, there are few different metrics that we will focus on, but not on phases.
Okay.
But phase is something that you should be aware of when it comes to talking about some of the standards like
A
11.
standard. Okay.
Yeah, 11n uses something called as the
Okay.
MIMO, right? MIMO technology
Mimo. Okay.
or
Multiple in
beamforming.
multiple out. Okay.
Beamforming, right? So these kind
Yeah.
of technology that were introduced with 11n, they utilizes these phase differences for their advantage. Because right now we are talking about that, hey, what if what if one wave cancels out each other? I will have potentially bad user experience. Now in 11n, these are some of the technologies or some advancement in the technologies that was made that uses this aspect of in and out of phase, uses it to its own advantage to provide a better user experience. So that's why we need to just understand the little or have at least some basic understanding of phases.
Okay. Good.
Yeah. Okay. Cool. Any other question on phase? Okay, cool. Now, one of the major concept in Wi-Fi, and this is something that we will hear day in, day out when we speak about Wi-Fi, is the term called frequency. Right? And this is something that we can't really escape when we talk about Wi-Fi. And this is one of the critical aspects or the critical building block of a wireless as a technology. Now, frequency itself as a definition, it refers to the number of waves that passes through a fixed point per second. So for example, let's say that this is a wave. Now, I'm observing this wave from this particular point in space, right? Now, at any given point in time, if I want to measure how many waves or how many complete cycles, and remember the complete cycle of a wave is when it starts from an origin point and then come back to the origin point after it goes from goes up to the crest, back to the trough, and then back to the origin. So this is one cycle. Now, when I'm observing this wave from this particular point in space, if I want to see or if I want to calculate that how many cycles have passed this particular space or this particular point in 1 second, right? Complete cycle. Remember, it's a complete cycle. How many complete cycle of this particular wave has passed from this particular vantage point? That is known as that is marked as 1 hertz, which essentially means that we have one wave per second that is passing from a particular vantage point. So that's the calculation that you have. So one wave per second at a specific point, if it has passed, again, from a specific point, if one complete cycle has passed in 1 second, that equates to 1 hertz, right? So reiterating the definition one more time so that it solidifies. Frequency will refer to the number of wave cycles or the complete wave that passes a fixed point per second, and it is measured in hertz. Now, as we move along, this is the most basic unit that you can measure the frequency in. If you want to move along, there is also a measurable unit of frequency, which is the kilohertz, which essentially means that you have 1000 waves which are passing this one particular point in time. Similarly, 1 megahertz, 1 megahertz would mean 10 to the power 6 waves per second. Now, as you can imagine, 1 gigahertz would mean that there are 10 to the power 9 waves passing per second. And imagine the sheer number and the magnitude of it, right? This is 10 to the power 9. So it will be what? About billion with a B for boy, right? About 1 billion waves passes in 1 second at one particular time. Now, you are probably getting in the space by looking at this number, 1 gigahertz, that we are now reaching in the space where Wi-Fi operates, right? As we, since we, most of us have worked into the Wi-Fi as a technology domain, we now know that Wi-Fi operates in the frequency band of 2.4 gigahertz, 5 gigahertz, and now even in 6 gigahertz, right? So it falls under this category of the frequency range. And that's why we say that 2.4 gigahertz is a frequency range where the Wi-Fi operates, right? Similarly, 5 gigahertz is a frequency band. 6 gigahertz is a frequency band where Wi-Fi operates. So again, imagine that on all these bands, on all these different frequencies, there are billions of waves that are passing every single second. And all these waves are used by the devices in order to send and receive data. And this incredible speed is what allows us to make use of these available RF characteristics to have these high throughput applications work in real time over the wireless communication. Right now, along with frequency, we also have an important term, which is the wavelength. Now, this is also quite a critical piece of the Wi-Fi as a technology itself. Oops. Give me 1 second. Yeah. So wavelength is again one of those things that we as a Wi-Fi engineer should be aware of, because this is something that will impact the design of the wireless or the deployment of the wireless. Now, remember that frequency was measured as how many waves that has happened in 1 second, right? Wavelength, on the other hand, is the physical distance from one point. And let me draw that wave one more time for us. So wavelength is actually this physical distance that you see in this particular wave from one point of a wave to the same point in the next cycle. And it is important for us to understand what do I mean by that. So for example, consider this is a single wave cycle. Now here, the starting point is this, and maybe I'll choose a different color so it'll make some distinction. Okay, this is better. So this was the starting point of the wave, right? It went to the highest point, went back to the trough, and then starting point again, right? Now, remember that, as I said, that this wavelength is actually the physical distance from one point in a wave onto the same point at the starting of the next cycle. So here it has completed its one cycle. Now, whatever starts from here, it is actually a next cycle, right? It will be a next wave from here on. So this physical distance that it has traveled from here until this point, this physical distance is known as the wavelength. Now, this is not necessary that we measure wavelength from the origin point and back to the origin point. We can also measure the distance from, let's say, crest to another crest, or one trough to another trough, right? So it's just that the point where you measure this distance has to be the same until the next cycle begins, right? Irrespective where are you calculating it from. But from our perspective, as wireless engineers, we should be aware that this is what the wavelength is. It is the physical distance that we are talking about for one complete cycle. Now, this wavelength, unlike frequency, which was measured and calculated in hertz, wavelength is denoted with a symbol lambda, right? This will ring some bells back to our physics lessons back in the school, right? So wavelength typically in the Wi-Fi world is measured in centimeters or maybe in millimeters. And in some documentation, you may even find in inches, right? Because it is the actual